Sometimes I have questions. Do I have the right to have fun in my lab doing this research? But on the other hand, you have teaching. You see that directly in the eyes of the student when they understand something. Yes, I'm doing something for society.
I suppose it's a question for all of us, whether to have fun or attend to your responsibilities. And it's clear, listening to Anne Lullier, that she takes her teaching duties very seriously. Not, I think, though, that she doesn't also have fun doing so. The duties attendant on being a Nobel laureate are also ones that she takes seriously, although one might think of her as a reluctant Nobel laureate, not perhaps asking to be thrust into the limelight like this. But now that it's there, she intends to do a good job. So do join me for this most thoughtful conversation with Anne Lullier.
This is Nobel Prize Conversations. Our guest is Anne Lullier, one of the recipients of the 2023 Nobel Prize in Physics. She was awarded for experimental methods that generate attosecond pulses of light for the study of electron dynamics in matter. She shared the prize with Pierre Agostini and Ferenc Krauss. Your host is Adam Smith, Chief Scientific Officer at Nobel Prize Outreach. This podcast was produced in cooperation with Fundación Ramón Areces. Anne Lullier has been Professor of Atomic Physics at Lund University since 1997. In this conversation, you'll hear her talk about her new role as a role model, how she doubled her prize by winning it for both France and Sweden, and about learning a new language by using it to teach advanced physics. But first, Adam wonders what it's like when your innate curiosity opens the door to a whole new field in physics.
One can't really imagine what it's like to be at that forefront where you're really exposing things you think are there, you imagine how they'll be, but then you see them for the first time, which is what you do with your light pulses.
Yeah, except we are not alone. So it's not like, climbing the top of a mountain for very, very first time. So because we are still many in the world doing similar things. And then you never know what you see is really interesting or not. You need some time to understand, analyze, and really be able to judge if this is the first time. Yeah.
It must be an interesting balance between, as you say, being part of this worldwide international effort, which is itself so exciting, and also obviously wanting, just the very human thing of wanting to be the first, wanting to see things for yourself. How does that balance between the individual and the team work in your life?
I mean, first, I think you are talking a little bit too much about competition. It's really not like that. And it is absolutely a team effort, especially experimental physics, what we are doing. It's a team effort. I mean, the reward is to find new things and to have beautiful results. You know that they are beautiful if there are no noise, if you see a clear variation or something. So this you know almost immediately that you have good results or not. I think the society should not see that as sport where you win a gold medal. It's not that. And the Nobel Prize is awarded to a discovery. And it's not personal, it's a discovery. That's the important focus.
Yes, indeed. In 1987, you were part of this team and generated these high-order harmonics by hitting inert atoms with high-energy lasers. Were you immediately aware that there was something of deep interest there?
Yes, actually I was. And I remember this moment very, very clearly. I mean, it's really, it's sit in my brain. But I can't say I could see that this was important. The only thing I can say is that it was very exciting, very, very fascinating. And what I felt is that, I want to know more and I want to understand better. So it was more an intuition than a clear realization of the importance. Yeah.
So often, again and again in these conversations, we come to those moments where intuition plays such a strong part. Somehow you've developed in the right way to be able to spot what is interesting. I know teaching is incredibly important to you, and it must be one of the things that you try to instill in young people, the feeling for what is important.
Yeah, and of course it's very difficult. I can only talk through my experience and through the way I am functioning as a scientist. And I'm not saying this is the right way and this is the way, or it's how I function. I very often follow some kind of feeling, intuition. Maybe it's more, on the artistic side than on a rigorous scientific side, but probably it's a little bit of both. But yes.
So Adam, Anne L'Huillier was awarded the prize for the production of attosecond pulses. What was her contribution?
Well, she started the field. It was her observation of these overtones in her experiments that began the whole thing.
And if I understand correctly, I think her experiments involved transmitting laser light through a noble gas. Is that correct?
Exactly right. She used high-intensity lasers to irradiate xenon gas, an inert gas. And the oscillating electric field of the laser excited the electrons in the xenon atoms. In fact, it gave so much energy and altered their motion so much that at times they have enough energy to escape the atom. But then the electric field, which is oscillating, changes, and when it changes, they get recaptured by the atom. So they're sort of going up and down. And as they do so, they emit energy in the form of photons, particles of light. And it's those photon emissions that she observed.
So that must have been a rather remarkable moment when she made this observation.
I think it was. What I think was unexpected was that she saw multiple photon energies, all integer multiples of the original laser frequency, in the same way that a musical instrument generates often not just one note, but overtones above that note. So she was seeing a whole range of different ionization frequencies. We're used to the idea of harmonics in music. This was harmonics in light.
So that's really interesting. But why are harmonics in light important? What's the application or use of that?
Well, it was noticed that these harmonics were produced in little trains of pulses. And what you got was maybe 1 to 200 attoseconds worth of light pulses. And so it suggested that, you suddenly had a way of generating very short flashes of light. But there was a very long way to go between that initial observation and the actual production of something that could be reproducibly and definitively said to be a useful attosecond pulse. And Anne L'Huillier herself talked about how that process took a long time.
This is a journey that took time. And it was not clear at all that this would be possible. And there's still a long way to go, by the way. This journey is really far from being finished. First of all, the idea that possibly these harmonics could, in the time domain, could be a sequence of very, very short light pulse. This was proposed, I would say, a couple of years after the discovery of this high harmonics plateau that we did in 1987. It was a natural idea for people dealing with lasers, with mode locking, because you have a similar process in lasers. But it was not clear at all. And actually, I was one of the skeptical persons because at that time we were doing simulations and we could actually check numerically. The result at that time was, no, doesn't work. But this idea was too good not to continue and investigate. Can in certain conditions we can have these attosecond pulses? So it took us, I think, 14 years to really settle this question. And this is also why the measurements by the two core laureates, Pierre Agostini and Ferenc Ross, were so important. They really show experimentally that, yes, one could produce attosecond pulses of light was terribly important.
It's interesting to think of that time scale, because when one tells the story of it, it all becomes compressed and it's one thing leads to another. And I suppose it's unusual in the world outside things like science that anybody follows a train for so long. 14 years is a long time in most people's lives to follow one thought, if you like. But I suppose what drives you throughout that is the curiosity and the phenomenon, so that it's not just that you're following that, but you're deeply interested, as you said, in the nature of the harmonics and the nature of the physics behind them.
Yes, exactly. And still is. Now it's not 14 years, but 37 years. We are still working on the basic process itself and try to understand it even better, and especially to control it even more.
It's wonderful that you find a problem that sustains you for 37 years.
Yeah, it's incredible, isn't it? I'm amazed myself. I've been so lucky.
Do you ever wake up of a morning and think, maybe there's another problem?
No. No, but I can think about still very fundamental thing around this during night or something.
Obviously, of course, everybody has their problems along the way, but it sounds like a sort of dream journey to a certain extent. And when we meet young scientists around the world, they're aware of the dream, but they're also, these days, terribly burdened by all the sort of things around science, the paraphernalia, the need to get published, get jobs, all of this. And it seems to worry them greatly. And there's a contrast between that concern and looking at your path and thinking, gosh, how wonderful.
Yes, I mean, I also had problems on the way, obviously. Things don't work all the time. I changed country in the middle of that, and it was not easy at all to find a new job and to be able to continue. I have had years without much funding. I have had years where experiments continue not to work during... So I have had my share of difficulties. But I guess I am very obstinate person and also passionate. I mean, the interest of the subject probably weighted more than the difficulties and the problems you can meet. Plus, you also meet, things suddenly work. You have an application that goes through. You have a good article that also goes through. So you have but that's a little bit like everything else in life. Some things work, some things don't work. The important is to continue going and to enjoy the good things that are happening.
Am I right that when you decided to move from France to Sweden, your dedication and, if you like, your obstinacy came out in the fact that you managed to learn Swedish well enough within a year to be teaching in Swedish?
Yes, I had no choice really, because I was going from a system in France, which was a research institute, no teaching, to a university system in Sweden, where it's important to have teaching merits. So to be able to come in the system in the right way, I really had to teach and to accept all the opportunities that were given to me. So unfortunately, what happened is that one of our colleagues here in Lund passed away abruptly, and he was teaching laser physics. And I was given the opportunity to take his course in Swedish. And this was maybe not 1 year, but 2 years after I had moved. And this was a challenge, which I don't know how my teaching was, but my Swedish really improved during that period.
And now do you feel yourself Swedish, French, a mixture?
I really feel both. I have a foot in both countries. I have lived half of my life in France, almost same number of years now. I have two sons. One is living in Sweden, one is living in France. So I really feel both. And this is one great thing, what is happening with the Nobel Prize now. This prize is the two countries say they have gotten a Nobel Prize laureate. And I'm happy that it's doubled in two different countries. I would say it's not shared, it's really doubled.
That's nice.
This increased the number of invitations, but it's also very, very nice. And I'm very touched by this The attention from Sweden is kind of obvious, but the attention from France was not obvious to me that this would happen. But it does happen very, very much, and I'm very touched by that. And I am trying to accept those invitations from France.
It's nice that it's, again, not competition, but teamwork between...
Exactly. It's exactly the right term, and it's very nice.
So, we've mentioned before the lovely international nature of science. Do you think it makes any difference at all where people come from? Do you see different scientific traditions sort of being manifested in the way that people in the lab behave and think? I suppose what I'm asking really is it a great positive that you have science coming from different countries where people think a little bit differently, or is it just one amalgamated way of thinking?
I like to work with a group where people come from different countries, and where they're both women and men, obviously, because I do think there are differences. Of course, there are differences between people. So you can't make the difference, oh, he thinks this way because he's Spanish, or it's mostly because this person is this person. But still, the fact that the research group is diverse, I think it's very nice, and it's also very pleasant. And this is something I like very much. And I also remember that one motivation with research was actually this meeting people from other countries and traveling, and this is part of the attraction.
How about language? I remember Leo Eseki saying that he feared a little bit that if science was all done in English, that you'd lose something from, at least from a Japanese perspective, that there was a Japanese way of thinking that was reflected in the way that the language worked, that somehow translated into the way people thought about science, and that you'd lose something if people weren't thinking scientifically in Japanese. I don't know whether there's any truth in that, but it was an interesting perspective.
Yeah, it is. I mean, the different languages have their own culture, if I can speak like that. And for example, I think the French is very precise. You can express yourself, especially feelings, much better than in English. But this is the way it is. Science is now, we have an international language, which is English. And we write in English, and I think it's great. If this was not the case, it would be very complicated. I like very much that we can, there is no barrier because of the language.
I can't resist asking you whether your knowledge of Swedish helps you think differently.
That's a good question. I don't really know. I think I pass on this question. For me, Swedish is the language of everyday's life now, and English is the language of science. I'm using every day the 3 languages, that I can tell you. And especially now with the Nobel Prize award, I'm doing lectures in Swedish, in French and English, almost the same amount. This is a very interesting process. So I'm talking about the research actually in all 3 languages.
First of all, how brilliant. But which do you actually think in? Or again, do you think in all 3? If you're just reflecting on your own without anybody demanding that you speak this or that language, do you reside in one language primarily?
Probably French. This is my mother language. But I don't really know, because I am switching so much so that it's not clear, when you are in a country, something, which language I'm thinking. But in my case, it's so much switching between the 3 languages that I don't even think about it. That's just automatic.
It must be a huge advantage. I wonder, do you worry about the fact that the tools, technological tools, are making it so easy to translate that young people are not going to bother to learn languages anymore because their phones will do it for them?
My opinion on that is that, this kind of question arose periodically in the human history. What happens when a computer arrives? Does it mean that we cannot calculate anymore use your head? What happens when we had this transition between, what is the name, writing machine and the computer. I mean, there was also a fear that this would degrade the ability of a human being to do some task. Probably it does, but it is also a progress. So somehow I think the human society is going to, of course, to make use of these new techniques and the translation and artificial intelligence. There will be a learning process. Probably we will, at least some of us will lose some ability, but we will learn other abilities. I think this is a transition that somehow we will go through. And I think it will be, hopefully this will be a positive transition.
It was it was fascinating that your English, which is utterly fluent, you didn't quite have the word for typewriter there, because a typewriter is totally obsolescent. So nobody has the need to say the word typewriter at all anymore. It's something that you put in a museum. And yet it was omnipresent not long ago.
This is what happened with my English. My English of the everyday's life is kind of gone, unfortunately.
It seems to be very much there, not gone. But anyway, let's talk about the importance of students a little bit. What does the teaching add to the research, if you like?
For me, it adds a lot in different ways. First, something I want to say about research and teaching as well. For me, research is also the interaction with other people is so important. And this I liked very much. This is something you do with other people. And that is terribly important. And now about teaching. To me, it's a balance in my work, because I like what I'm doing research on these higher harmonics at a second pulse, but sometimes I have questions. What is the interest? Will this be ever interesting for the society? We're using, for the most part, taxpayers' money. Do I have the right to have fun in my lab doing this research? There is a feedback, but it takes years. And I think now we're getting towards a little bit application. So I start to see a little bit the feedback that this research can give to the society, not only increased knowledge, but also applications. But it takes years and it's not clear. So you have that. But on the other hand, you have teaching, where what you do is giving you direct feedback. You see that directly in the eyes of the student when they understand something. Yes, I'm doing something for society. So this balance for me, that is very important.
I can see absolutely how it sustains one.
Yeah.
And I suppose it perhaps takes us to the point of diversity in science. It's an extraordinary and awful thing that you are only the fifth woman out of 224 different people who've been awarded the Physics Prize in its existence. That indicates that there's an awfully long way to go with that one snapshot. How do you think about promoting and the importance of diversity in physics?
I think it is important. It is important for women, of course, and it is also important for physics, not to miss half of humanity. So I feel this very strongly, that I have a role that my other men colleagues don't have, which is to try to inspire the young women, the girls. This is something I'm doing a lot these days, to speak in schools, in universities, of course, but also in schools about the Nobel Prize, with the idea to maybe inspire young women and to tell them that it's possible to do science, to do research.
So what do you think is, it's obviously the $64,000 question, what is the barrier that has so far made it so difficult? Obviously there are many barriers, but what would you highlight?
I mean, if I knew the answer to this question, I would be very happy. I don't really know. I think one is the lack of models, probably. Another reason is the stereotypes, to do the same as the others in my category, something like this, which is it's similar, actually, not quite, but a similar idea with model. Then, of course, you have more practical issues like it's a difficult career, especially at the age of around 30, where you should get permanent position. And this is the age where normally you can get children. So this is a little bit problem. This can be, of course, in some countries really help. Like I think in Sweden, there is a very good system for that. The society and the school and kindergarten systems. So this is more a kind of practical issues, of course, but which, of course, play a role.
And all of that has to be put into place, the childcare, the support systems, the idea, basically, I suppose, that you don't have to dedicate 100% of your life to being there, doing the science at that period in time. But how do you also get over the perceptual barrier that it's a male-dominated world?
Having more models.
Yes.
This is what I said in my speech at the Nobel banquet. I think things are changing. I can see during the 40 years of my career that things are different, that there are more women now in the research groups, that there are more women taking physics university studies. So this is a change that will take time. So I think we should not be too impatient. We should not force quotas. It has to be a little bit natural process, of course, help by awareness, maybe by some programs, I don't know. It will take some time, but I think it is ongoing. At least in what I know, Europe and United States, I cannot say too much about Asia and Africa.
I suppose you were given a very broad and interesting perspective on worldwide physics from being on the Nobel Committee, which you were for a number of years. Was it from 2007 to 15? That must give you an extraordinary insight because you see all the nominations, you see all the physics that people out there are thinking is worthy of this particular recognition, and it must expose you to a bewildering and wonderful variety of people and ideas.
Yes, this was absolutely, it was a very, very interesting task to serve on the committee. But I cannot tell you, obviously,
you can't tell me
anything about it.
Nothing about it. I'm fully aware of that. But it is notable, for instance, that for that period that you served, there were no female laureates in physics. So I just wonder whether, I suppose you can't even talk about that. It's completely off the table. But it's interesting to know whether you see whether that backs up this idea that there's a change going on, that there are more females coming through.
Yeah, I mean, one thing I can say is that the Nobel Prize is looking back in time, a little bit by definition. And that's because this requirement by Alfred Nobel that this has to be for the benefit of humankind. So often when you have a discovery like high-order harmonic generation, it takes 36 years to get to a point where, yes, you can see that this is useful for mankind or can be useful for mankind. So because of that, the committee is of course, sometimes this is not the case when you have, for example, the gravitational waves, this goes very fast. But most of the time, it's really looking back how the situation was 40 years ago. And I think the situation has really changed the last 40 years. Now, I'm saying that not as a previous committee member, but really as a researcher simply.
Do you feel that the situation for science in general is looking bright?
I really don't know the answer to this question. I think it is, but I think, by personality optimistic, and I also a strong believer of science. I think science can solve many problems.
Your own research is a beautiful example of a totally unexpected finding leading to application. And I suppose that you can't necessarily go after the solution because the solution may come from totally unexpected places. You have to go after science in general and be opportunistic and aware and have the right intuition to spot what's interesting.
Yeah, and this is why it's very important that the basic science can continue. Because I think the great discoveries in science almost always come from unexpected areas. So this is why it's terribly important too that there is a continuation in funding basic science by the politics.
Which places an enormous amount of trust in science. People really have to believe that it's going to work. And that's why it's so important that people can understand that and have the patience and optimism that scientists themselves have.
Yeah.
I love this word optimism you keep coming back to. What, as an optimistic person, do you think optimism is a very important personal characteristic for a scientist?
Maybe not so much optimism, by obstinacy. I think that is very important.
Would your family call you obstinate as well?
Yes, yeah.
It strikes me that you're not somebody who particularly likes talking about yourself.
No, and this Nobel Prize is putting me in, what do you say in English?
The spotlight?
In the spotlight, exactly. And this is a little bit against my personality. So I'm forced to be someone that maybe I am not naturally, which I accept. Let's put it this way. But hopefully it's not during too much time.
Absolutely. No, I can see that it interferes. And being reluctantly famous is difficult. Yes.
I mean, I'm not complaining. As I said, I accept it and I see not the advantage, but the consequence. And this is why I'm taking very seriously this role as maybe model, but as I would say inspiration to the younger generation. Yes, but it's not something I would have applied to, if you see what I mean. Certainly not. I rather like to do my teaching and to do my research, write a book. This is what I want to do. And now I'm doing something else, which is this kind of outreach activity because of all of this attention because of the Nobel Prize.
But I like that, since you are cast into this role of being a role model, it's very apparent that the role does not involve seeking for fame, and it's a very serious role. You approach this with a great degree, as you say, of obstinacy and seriousness, and that's what you have to be to get things done. What's the book going to be about when people like me leave you alone and you have time to write it?
I want to write a textbook for beginning students, PhD students. So it's still it's a scientific book, but it's my idea is to write a textbook because I think I've learned so much about high order harmonics and attosecond pulse, and we have developed simple models in many aspects of it. So I would like to write this down. So hopefully when all of this Nobel wave is over, I can find time to write this book.
I very much hope you do. What language do you write in when you write it?
In English.
Thank you very much for allowing me to steal this period of time with you anyway. It's been a joy to talk to you. Thank you.
Thank you. Bye-bye.
You just heard Nobel Prize Conversations. If you'd like to learn more about Anne L'Huillier, you can go to nobelprize.org, where you'll find a wealth of information about the prizes and the people behind the discoveries. Nobel Prize Conversations is a podcast series with Adam Smith, a co-production of Filt and Nobel Prize Outreach. The producer for this episode was Karin Svensson. The editorial team also includes Andrew Hart, Olivia Lundquist, and me, Claire Brilliant. Music by Epidemic Sound. If you'd like to hear another conversation with a scholar who's connected to Sweden, check out our episode with the 2022 Medicine Laureate Svante Pääbo. You can find previous seasons and conversations on Acast, or wherever you listen to podcasts. Thanks for listening.